You ever stop and think about how your phone just knows the fastest way home during rush hour? Or how, after a massive earthquake, aid workers seem to know exactly where to go? Well, the answer is this incredible technology that's working all around us, usually just behind the scenes. Today, we're pulling back the curtain on Geographic Information Systems, or GIS. To really get a feel for just how powerful GIS is, let's start with a scenario where the stakes couldn't be higher. Picture this. A massive hurricane has just roared ashore, and right now, it is pure chaos. You've got roads completely underwater, power lines are down everywhere, and literally thousands of people need help, fast. You have limited resources, limited time. Where do you even begin? How do you possibly turn that overwhelming flood of information into a plan that actually saves lives? Now this visual right here is the key. See, a disaster isn't just the hazard itself, the hurricane or the earthquake. It's what happens when that hazard slams into a vulnerable community. The real danger zone, the heart of the crisis, is that overlap. To do any good, you have to understand that intersection perfectly. You need to see the storm's path, the flood zones, where the hospitals are, how many people live in each neighborhood, which roads are still open, and you need to see it all at the same time on one screen. You need a system that can handle all that spatial information. And that system, the one that can make sense of all of this chaos, it has a name. It's a field of study sometimes called the science of where, which is all about putting every single piece of data into its proper place on the map. Okay, so formally, it's called a Geographic Information System. At its heart, GIS is basically a super smart map. It's a tool that helps us see patterns and relationships by connecting data directly to a location. If it has an address, a coordinate, a zip code, you can put it into a GIS. The easiest way to wrap your head around GIS is to think of it like stacking a bunch of clear sheets on top of each other, like on an old school overhead projector. Each sheet or layer shows a different kind of information, but they all line up perfectly over the same geographic area. So, how do we build one of these maps? Well, first you start with a base map, the physical landscape, right? Mountains, rivers, that sort of thing. Then you lay down a vector layer. Think of this as anything with clear, sharp edges, roads, buildings, property lines. After that, you can add a raster layer. This isn't about distinct lines. It's more like a heat map showing continuous info like elevation or temperature. And finally, the really cool part, you stream in real-time data from satellites or sensors. When you stack all those layers together, that's where the magic happens. You get this incredibly rich, multidimensional view that reveals patterns you would never, ever see otherwise. And this is so important. GIS is so much more than just software. As this quote gets at, it's really a new way of thinking. It's like learning a new language that lets you see how everything is connected, from our social systems to the environment. It gives us this truly holistic picture of our world. And having that holistic view, well, that's exactly what we need if we're going to have any shot at tackling some of the biggest challenges on the planet. So let's take a look at how GIS is already mapping out our future. Think about it. Nearly every major global challenge has a where component. And because of that, GIS has become an absolutely fundamental tool for trying to achieve the United Nations Sustainable Development Goals, which is basically our shared blueprint for a better future. Take life below water, for example. GIS maps like this one are used to track marine protected areas, the health of coral reefs, and our mangrove forests. This helps us understand and, hopefully, preserve these incredibly important ecosystems. Or how about the goal of zero hunger? GIS can analyze satellite data to map out agricultural productivity, down to the field. This shows us which areas are doing great, and more importantly, which ones need support. It's all about making our food systems smarter and stronger. And this dashboard just brilliantly illustrates the sheer scale of the problems GIS can help us visualize. This thing tracks water stress across the globe in near real time. It highlights exactly where 1.7 times billion people are facing water insecurity. This is actionable data on a massive global scale. But it's not just about these huge global issues. Right down at the city level, GIS is used for everything, from planning the most efficient waste collection routes to figuring out the best rooftops for new solar panels. It's helping us build the sustainable cities of tomorrow, one data layer at a time. Okay, but a tool this powerful, one that can literally map our entire world in such incredible detail, well, it's going to come with some serious questions and responsibilities. It's not a silver bullet. Just on a practical level, GIS systems can be really expensive to set up and maintain. They're not exactly user-friendly, you need specialized training, and trying to get different kinds of data to play nice with each other can be a nightmare. And of course, there's the classic rule: garbage in, garbage out. If your data is bad, your map will be useless, or even worse, misleading. Now, here's a fascinating twist in modern GIS: citizen science. This is where regular people, like you and me, contribute data through our phones. In a disaster, that on-the-ground info is absolutely invaluable for first responders. But it also opens up a huge can of worms around data privacy. Who owns that location data you just shared? And how can you be sure it won't be used for something you never agreed to? And that brings us to what is, without a doubt, the biggest challenge of all. And it's not a technical one, it's ethical. When you have the power to map human behavior with this kind of precision, you take on an enormous responsibility. The absolute key is to make sure this technology is used to empower people, not to exploit them. It's about building trust and protecting the privacy of everyone, especially the most vulnerable communities who could be harmed by the misuse of their data. So this is where we're at. The science of where has given us this almost godlike ability to see and understand our world. The technology itself isn't the question anymore. The question is us. With all this power at our fingertips, what kind of world are we going to choose to build?